Hi, good morning everyone. Hope you all are fine at home, and I hope so that you are understanding the exercise 10.6 concept very well. So here I'm going to continue with the 10.6 part 3 because there is number of questions that divided into 3 parts. So this is the last part of 10.6 exercise. So here I'm discussing few questions, important question of this exercise. So in this your 24th question, first part, you have to find the sum of the series up to infinity, and your series is 1 plus 1 plus a r plus 1 plus a square, then r square up to infinity. So you have to find the sum of the series. So before finding the sum of series, if you look at this is 1 plus a, this is 1 plus a square. So better we convert this into some square formula like a square minus b square, a cube minus b cube, that form. For that we have to multiply, divide, and multiply numerator denominator both, or you can say that multiply and divide by 1 minus a. So if I do like that, then sum is equal to, if I keep outside at 1 upon 1 minus a and inside multiply all the term with 1 minus a, so this will be 1 minus a plus 1 minus a, 1 plus a r, then plus again 1 minus a, then 1 plus a square r square up to infinity. So up to infinity. So this is my series. If you look at this, this is 1 minus a, 1 plus a, this is a square minus b square formula. This is 1 minus a, 1 plus a square. This is a cube minus b cube formula. So we convert these two terms into the formula. Then my required series become 1 minus a, 1 minus a plus 1 minus a square, because first position is 1 r, then again 1 cube minus a cube. So anything, so 1 multiplied by any times, that will be considered as 1 again. So this is a cube minus b cube formula, a square minus b form, a square minus b square formula, and so as it is we have to do. So now we have to separate the series. Suppose if you multiply r, this one, so this become r minus a square r. So if r square multiply this become r square minus a cube r square. So now you have to separate the terms. If I separate the terms here, so this is 1 into r and r square up to infinity. So this is my first series. Now after the, if are you going to equate the second term, so in this second term, before the second term there is a negative sign, so we keep negative sign outside, so that become a square r plus a cube r square up to infinity. So this series will be made like that. Now if you look at it, this is GP series, this is also GP series. Here in GP series your a term is 1 and r is r. Here if you look at this, your a term is a and r is ar. Your ratio in this case is ar. So when you apply this first term and the ratio in each series, so your sum of the series of this series will become 1 upon, because sum of infinite series is a upon 1 minus r. So in place of a there is 1 and 1 minus r, then minus here a upon 1 minus ar. Now you have to solve this one. So what I will do, I will find the LCM of this one. 1 minus r multiply 1 minus ar implies 1 minus a. So if you take the LCM, 1 minus ar minus a, then 1 minus r, it will be multiplied. Then here 1 minus r and 1 minus ar. So now you open the bracket here. So 1 upon 1 minus a, 1 minus ar, 1 minus ar minus a plus ar upon 1 minus r, 1 minus ar. So this ar will be cancelled, only 1 minus a is left. So same here, 1 minus a is left. This is 1 upon 1 minus a, 1 minus a upon 1 minus r and 1 minus ar. So this 1 minus a and this 1 minus a will be cancelled, and our required answer is sum of the term is 1 upon 1 minus r and 1 minus ar. So this will be my answer in this case. Now in your 27th question, next, if S1, S2, S denote respectively the sum of n terms. S1 is the sum of n terms of the GP series, like this. If you represent as sum 1, S1. So S1 according to the statement is sum of the n terms of the GP series. Okay, and S2 represent as sum of 2n terms starting from 1. So that will be 2n terms. And S represent as infinite number of terms, that is starting term 1, term 2 up to infinity. First what you have to do, you apply the formula in this term 1, term 2 to term n, term 1, term 2, term 2n, and term 1, term 2 up to infinite. If you go with this is a normal formula of GP series, sum of GP series. So that will be represent a 1 minus Rn upon 1 minus R. Here also a 1 minus R 2n upon 1 minus R. Because here your last term is 2n and first term is a. Here in infinite series your required formula is a upon 1 minus r. So this is value we consider as, this is S1 value, this is S2 value, and this is your S infinity, or you can write sum of infinity terms, that is represent as S. According to the question, that is represent as S. So here now what you have to do, first you have to pick the left hand side term. Your left hand side term said S1 multiply by S1 minus S. You replace the term, S1 term is a 1 minus Rn upon 1 minus R. Here also within the bracket your S1 term is a 1 minus Rn 1 minus R, and here your S term is a upon 1 minus R. So if you look at this a upon 1 minus r, this is a upon 1 minus r is common in these two terms. So what you will do here, so you will take out common a upon 1 minus r. If I take out common here, so that will become a square upon 1 minus r whole square, and outside already 1 minus Rn is there, and what is left inside the bracket, 1 minus Rn minus 1. So 1 will be cancelled. So what is left? Minus Rn. So what is left? A square 1 minus r whole square 1 minus Rn, then minus Rn. So this will be your required answer, a square 1 minus r whole square 1 minus Rn minus Rn. So that will be your required answer of left hand side. Now we have to move to the right hand side. In right hand side your statement is S1 minus S2 and S. Okay, so your S1 value is a 1 minus Rn upon 1 minus R. Your S2 value is a 1 minus R 2n upon 1 minus R, and outside your S value is a upon 1 minus R. Okay, if you look at this again, this a upon 1 minus R, this is a upon 1 minus R is common, so we take it out. So that become a square 1 minus r whole square. Now what is left in the bracket? 1 minus rn, and minus is outside, and 1 minus rn. I am going to directly open the bracket here. If you directly open the bracket, so that will gives you minus 1 plus r raised to power 2n. 1 will be cancelled. So what is left? Minus rn r raised to power 2n. From these two terms, so what is left it here? A square 1 minus r whole square and minus rn plus r2n. But I need this term same. Okay, so if you check with this again, move to the left side or either to the right side. If you, because we need the same term here to make it left hand side is equal to right hand side. Either you can take minus rn common, so that will be left again 1 minus rn, or either you can multiply this minus rn with this, so that become a square 1 minus r whole square, so that become minus rn plus r2n. So that is the same term you got in the left hand side. So this is your right hand side. So if left hand side is equal to right hand side, so that is proof what you want to prove in this. Now in your 29th question, you have given in your question sum of infinite series is given to you 16 and sum of square of the terms. अगर आप टर्म्स का स्क्वायर कर दो, लाइक टर्म 1 स्क्वायर प्लस टर्म 2 स्क्वायर जो जीपी सीरीज की हैं, ओके, अप टू इनफाइनाइट, ये भी इनफाइनाइट है, तो उनका टोटल आपके पास गिवन है 153 3/5. Okay, so if you apply here sum of infinite term, that is a upon 1 minus r is equal to 16. If you extract a value from that, that is 16 1 minus r. Keep this as equation 1. Now come to this point, your term 1 value is a square, so this is a r square up to infinite. So when you open this one, 153 into 5 plus 3, so that is 768/5. Now if you have to find out this sum of infinite series, in this if you look at first term, your first term is a square, and your ratio here is when you divide a square r square by a square, so that is r square is left. So that is the first term and the common ratio of this series, because in this question you have to find the r value and term 4. So here a square will be cancelled, means common ratio is equal to r square. When you apply sum of infinite series formula, a upon 1 minus r, in place of a there is a square and in place of r there is r square, 768/5. So this is equation number 2. So now what you will do, you will put equation 1 in equation 2. Now here, after that, okay, so now when you got equation 1 and 2, now you have to put equation 1 in equation 2. You have to put this equation 1 in place of a in equation 2. So that becomes 16 1 minus r whole square by 1 minus r square, 768/5. So now you have to try to solve this one. 16 into 1 minus r whole square means 16 square 1 minus r square. So both term will be come under power square. So 16 square is 256, 1 minus r upon, here in the downward there is a formula of a square minus b square. So that is 1 minus r, 1 plus r is equal to 768/5. This will be cancelled. This will be cross multiply. 1 minus r, 1 plus r is equal to 768/5 into 1 by 256. 256 3s are 768. Only 3/5 is left. Now you cross multiply this. 5 minus 5r is equal to 3 plus 3r. Now when you cross multiply, you will get the value. This is 2 is equal to 8r and 1 by 4 is equal to r. 2 divided by 8 give me 1 by 4. Now here you get r value is 1 by 4. After getting the r value, you have to substitute this r value in equation number 1. Put r is equal to 1 by 4 in equation 1. So this is a is equal to 16, 1 minus 1 by 4. When you take the LCM of this one, this is 4 minus 1 by 4 is equal to 16 into 3 by 4. 16 into, so this is 16 into 3 by 4, 4 4s are 16, so that is 12. So your a value is 12 and your r value is 1 by 4. Now after getting the a and r value, next step is you have to find the fourth term of this question, or there is this GP series. So that is a r cube. A value is 12, r value is cube, that is 1 by 4 multiplied by 3 times 4 3s are 12, and my required answer is 3 by 16 is my required answer. So this you have to find. Other questions are we already discussed here. So I just quick review of the other questions, because already some of the question we discussed in the class. So here also you have to apply the same method to the other questions, like question number 22. So here in the question number 22, you have separated the series, like first multiply each bracket, separate the series x square, x4, x6 up to n terms, xy, x square, y square plus x cube, y cube up to n terms. Apply the sum of GP series formula in both the series separately. So that will be your required answer. So question number 23rd, we just do 24 as first part. So if there is 1 plus s, 1 plus x square condition is given to you, you multiply and divide by 1 minus x. So 1 minus x will be multiplied inside the bracket, and 1 by 1 minus x will be keep outside to balance the equation. Because if we multiply any number with ourselves, so same to balance the equation you have to multiply the corresponding term also to balance the equation. Here 1 minus x, this is the formula of a square minus x square, this is the formula of a cube minus b cube. So this is a square minus b square, a cube minus b cube up to n terms. Now you have to separate the terms. So this is 1, this is 1, this is 1 will be separate up to n terms. X, x square, x cube will be separate. Now next is you just apply the formula and arrange the terms. Next is we have discussed already some question, like, so if there is a question of the series 0.5, 0.5, 0.55, 0.555, जब आपके पास इस टाइप की सीरीज आती है तो आपने सिर्फ 5 ही कॉमन लेना है. 0.1, 0.11, 0.11 will be left inside the bracket. Now you have to multiply and divide by 9. So when 9 will be multiplied, that becomes 0.9, 0.99, 0.999, and 5 by 9 as it is. Now 0.9 will be written as 1 minus 0.1, and 0.9 as 1 minus 0.01, and 0.999 as 1 minus 0.001. Now you have to separate the term 1 separately up to n terms, minus keep as between the brackets, and 0.1, 0.01, 0.001 up to n terms. If it here, this is n, 1 is added n times, so n multiply 1 will be there. A term is 0.1, r is 0.1 raised to power n, because here r value is when you divide 0.01 by 0.1, that gives you 0.1. Here 1 minus 0.1 gives you 0.9. Here open the decimal. So when you open the decimal here, 10 will be cancelled, and next you take the LCM, 9n minus 1 plus 1 by 10n, and 9 will be multiplied outside with the denominator 5 by 9. So this is 5 by 9, 5 by 81. So that is your required series. Here, like if your this term is series also there, like 1 by 2 plus 3 by 4, 7 by 8 plus 15 by 16. Hint is also given to in your question. First you have to convert into the two terms, because if you look at 1 by 2 plus 1 by 3, this is neither a AP series neither a GP series. You have to separate the two terms. Like 1 by 2 will be written as 1 minus 1 by 2, 3 by 4 will be written as 1 minus 1 by 4, and 15 by 16 will be written as, sorry, 7 by 8 will be written as 1 minus 1 by 8. So now you keep the 1 separate, and 1 by 2, 1 by 4, 1 by 8. Now this is your GP series. Your A term is 1 by 2, R term is 1 by 4. So 1 minus 1 by 2 raised to power n, 1 minus 1 by 2. So why we use 1 minus Rn formula? Because ratio is 1 by 2, that is less than 1. So we apply this formula, A into 1 minus Rn upon 1 minus R. So after that you just open it, so that will be your required answer, n minus 1 plus 1 by 2 raised to power n. Now your 28th question. In this 28th question you have y is equal to 1 plus x square up to infinite. You have to find the value of x is equal to y minus 1 by y. You just apply the direct formula of this infinite series. A upon 1 minus r value is x, 1 upon 1 minus x. So here when you cross multiply that, just equate the x term, so that is y minus 1 upon y. And your other terms of the question is, your statement question is 30 and 31st question. In 30th question, a snail starts moving towards a point 3 centimeter away at a pace of 1 centimeter per hour. As it gets tired, it covers only half the distance compared to the previous hour. Because in this, how series will be made, a snail has to cover the 3 centimeter distance. You have to find in this how much time will the snail reach its target, how much time he will take to complete 3 centimeter distance. Because in the first step he will cover 1 hour, but in the next step he will cover up the half of the previous one. Half of the previous one means whatever previous value is there, that will be multiplied with the 1 by 2. Like 1 by 2 multiplied by 1 gives you 1 by 2. And when he moved to the next step, so for moving to the next step, this 1 by 2 multiplied by again 1 by 2 give you 1 by 4. That means for finding the next term, previous term will be multiplied by 1 by 2. That means your ratio is, R value is 1 by 2, A value is 1. You apply the sum of GP series of n terms formula and try to find the n value. But when I reach at that point, so here I get 1 by 2 raised to power n, but here after calculation I get minus 1 by 2. So that is not possible. So I can't make the square of that one, because base will not be equal to each other in this case. So this side it is not possible. That condition is that if snail move like it this way, so he will never reach at the proper place at the proper time. Okay, so next is your 31st question. A inventor of the chessboard. You very well know that there is 64 square, because this is 8 by 8 square. Square is there in chessboard, so there is total 8 by 8 64 squares are there. So in this chessboard, one inventor is playing, and he asked the king a reward of 1 grain of the wheat for the first square. If he covered the first square, so he will received 1 grain, and he will cover 2 second square, he will received 2 grains. For third square, for next square, because 1 by 1 when he just gain the square, जब एक एक स्केयर वो बढ़ता जाएगा, तो वो उसकी जो टर्म्स हैं, ग्रेन की टर्म्स है, किंग उसको उतना ही डबल करके उसको देगा. अगर वो पहला स्केयर कवर करता है तो 1 ग्रेन मिलेगा. अगर वो सेकंड स्केयर कवर करता है तो उसका डबल हो जाएगा, 1 का 2. अगर वो थर्ड स्केयर ग्रेन करता है तो जो पीछे वाली टर्म है उसको डबल हो जाएगा, मीन्स 2 से मल्टीप्लाई हो जाएगी. सो दिस केस में जो रेशियोज हैं वो आपकी 2 आ जाएगी, आर की वैल्यू 2 आएगी, ए की वैल्यू 1, और अप टू 64, क्योंकि उसने 64 स्केयर क्रॉस करने हैं, तो यहाँ पे टोटल 64 टर्म्स आएंगी. तो 64 टर्म्स का आपने टोटल निकालना है. सो रेशियो सेम आएगी, क्योंकि नेक्स्ट स्टेप के लिए जो प्रीवियस वाली टर्म है वो 2 से मल्टीप्लाई होगी, कि जितना पीछे उसको मिला होगा वही 2 से मल्टीप्लाई होगा, तो नेक्स्ट टर्म जनरेट हो जाएगी, नेक्स्ट ग्रेन्स जनरेट होंगे। तो a इंटू आर एन माइनस वन, आर वैल्यू इज 2, n value 64, so that is sum of 64 terms. Then sum of 64 term is 2 raised to power 64 minus 1. Then total grains given is 2 raised to power 64 minus 1.